My name is Joshua Iguno. I'm currently a staff member at Baba Sky Technology. My core responsibility, I specialize in UAV system integration and avionics support. Okay, for today, I'll be walking you through the topic, understanding firmware in UAV system. We will explore what firmware really is, how it works inside drones, and why it is critical for flight stability, sensor accuracy, motor control, and overall UAV system performance. Whether you're a developer, a pilot, or a tech enthusiast, by the end of this section, you have a solid grasp of the firmware foundation that powers modern drones. We'll be talking about firmware rules in UAV, fundamental concepts to advanced integration. I will try as much as possible to examine history, control theory, real-world application, and emerging research. First, well, before we go further, I have to explain what firmware is. Firmware is embedded software in UAV. Firmware is like the brain inside a device that tells it what to do. But note one thing, it is not a full software. Think of, think of it this way. If you if you have a drone, or let's say your drone is a body, the firmware is like its nervous system that tells the body how to move and respond. Firmware is also it controls the device behavior, acts as a bridge between low-level electronics and high-level systems. Firmware is a special kind of software built into the hardware. You can't see it like an app, but it's always working inside your drone. Firmware software is the software at the heart of your drone. It controls everything from your flight inputs to your battery management and everything in between. So having up to date firmware update is important if you are to operate your drone safely and reliable. By now, I guess a lot of questions will be in your mind. What is this firmware really about? And why is it actually even important? In a drone, firmware controls taking off, landing, stabilizing the drone in the air, checking or battery management system, and is also responsible for responding to your remote control inputs. Then moving further, we'll talk about different types of firmware. We have the bootloader firmware, the flight control firmware, ESC, electronic speed firmware, sensor firmware. But let's deep dive into what a bootloader firmware is like. Let me just give you an insight what it's like. Think of your bootloader firmware as the starter or ignition of the drone, just the same way you have ignition or a starter in your car or your bike. Before anything else works, the bootloader wakes the system up, loads the main flight firmware. Also note this, without this, the drones wouldn't even know how to even start. It's just like you having your drone and you just the idle doing nothing. Then we talk about the flight control firmware. This is the main brain of your drone that controls every other aspect of the drone. It handles your direction control, that is your left movement, your right movement, your up movement, and your down movement. It also controls your stability and balance in the air. And another critical aspect of the flight control firmware is how the drone responds to your joystick. You know, when controlling your drone, you control from it, your joystick. Your firmware itself for your flight controller is what makes flying smooth and very smart. Without your firmware, your FC firmware, your flight control firmware, trust me, the drone is as useless as anything. Then ESC speed controller firmware. As the name, the full meaning of the ESC is electronic speed controller firmware. This controls the motor, that is, how fast can your motor spin or how slow do you want your motor to spin. For instance, now if you want to actually go faster, the firmware actually helps you in going faster. If you want to decrease the speed, your ESC firmware help you control how fast or how slow your speed. Basically, adjust your speed to keep your brain and your drone stable. Then we have our sensor firmware. This manages all the sensors on board, like your GPS, your barometer, your gyroscope. The sensor firmware actually helps the drone to know, I think is actually one of the most important role that it plays, to know its position, detect the altitude at which the drone is, to keep the drone level, to stay leveled and safe. Now, the importance of firmware in the UAV, or to say, why does firmware really matters in UAV? Firmware really determines how well your drones perform. Let me break it down. Stability during flight. Firmware helps your drone stay balanced in the air, especially when it's windy or during turn when you're trying to change orientation. Without proper firmware, your drone will wobble or drift. The worst case scenario is possibly crash. Another importance of firmware in UAV is sensor accuracy. Firmware makes sure your sensor like the GPS, altimeter, your gyroscope give correct data. The way your drone knows its exact position, height, orientation all the time. Response time to command. When you move when you move your controller, firmware decide how fast the drone reacts. Imagine when you have your drone up in the air and you give it an input from your RC remote, and you respond, let's say 1 second later. It's going to be very disastrous. So your firmware actually helps to control the response time in less than a second, in milliseconds. Another critical importance of firmware in UAV is execution of automated mission. If your drone is flying a preset path, maybe you planned your mission for the drone for mapping or possibly survey, or better use case, delivery system. Firmware ensures that it follows that mission precisely without any human prop or input, especially when you are actually loading your commands, your instruction, your preset flight paths. The firmware takes control and does everything. Just sit down, relax, then the drone performs its mission. Then, last important is the fail-safe recovery system. If something goes wrong during operation, probably maybe like you lost signal to your remote control, you lost GPS, probably due to electromagnetic interference, especially if you are flying over um, electric line, power line, or probably and another important distinct use case is when you have low battery. Firmware triggers a safe return reaction to home or emergency landing. Now, hardware firmware relationship. Firmware, like I've said before in the previous slide, is a special kind of software that, that lies inside the hardware. More especially, it is stored in a part inside your hardware. That is why I wrote something down here. Firmware lives inside your microcontrollers and your SoC, that is system on chip. It is tailored to the hardware capability, ensures efficient use of your sensor, motors, and communication protocol. Why does this really matter? Firmware are custom made for the hardware it lives on. It knows what the sensors that are available. For instance, now, let's take your PC, your laptop, for example. Your firmware knows the total numbers of sensors you have, like your temperature, your battery management system, everything you can think of, your firmware knows every information about it. For our own use case here, our firmware knows how the motors are behaving, whether the motors is behaving erratically, or is slowing down, or is increasing speed. And another critical part is how it communicates with other parts of the sensor or other part of the hardware. So it basically helps the hardware work efficiently like a translator. I think your firmware is basically a translator that makes sure every piece of the drone is speaking the same language. Let me use this simple analogy. Think of the hardware as the body and the firmware as the nervous system, just like we have in the human parts, the human body, I mean, that knows exactly how the muscle. Now, for our use case, that is for our hardware, the muscle this time around is like, let me just use the motor and the eyes, the sensor should work together. Understand that firmware isn't one big block. It is okay. Firmware architecture. Understand that firmware isn't just a big block. It is built in layers like a cake. The way you normally have your cake stuck in layers by layer. That is how firmware are actually stacked. Every layer plays as its job and plays and pays and depends on all this to perform. That is your bootloader, OS abstraction, your middleware, and application layers. So for your OS abstraction, this is the base layer of the firmware. The bootloader starts the systems and prepare the environment, just like I said the other time, like the ignition system. The OS abstraction let the firmware run smoothly on different drone hardware. Think of the bootloader like the foundation of a house and a scaffolding. Then the middleware, as the name implies, is the middle layer. It connects hardware with the brain. Hardware includes sensors, driver that help the firmware understand sensors data, the Marvelink, a communication protocol for drones to control and to talk. It's like this translator between parts of the drone and the system itself. Now, the application layer. This is where the real action happens. It runs control loops to stabilize the drone, perform state estimation, meaning it figures out where the drone is, what it is doing at a particular time. It's like the pilot's drone handling movement, altitude, and flight plan. Each layer is built on one another. Together, they allow firmware to work efficiently, adapt to different hardware, and run complex missions. If I actually don't discuss or talk about the history, how it all started, I don't think I've already done any justice. Now, evaluation of professional firmwares, key milestones in UAV. In the 2000, at first, drones used proprietary firmwares, mainly built for military UAVs. These systems were closed source and not accessible to any public. Then in 2009, where the first open firmware became one of the, I think the first open firmware. This actually was the one that actually opened doors to researchers, hobbyists, and companies to build customizable drones. Then in 2011, PS4 framework was introduced as a modular professional grade open source framework. It is one which is widely used in research, especially and also in commercial drones, deliveries, what have you. There's some currently there's some um, agricultural drone that solemnly runs on the PX4 as we speak. In 2025, in 2015, I mean, around this time, when we started introducing AI, computer vision, helping drones to detect and avoid obstacles and fly intelligently. UAV firmware has actually grown from military code to powerful open source platform that supports innovation in commercial drones and in research drones. What is actually the difference between open source and proprietary firmware? Note, mind you, key difference: firmware can be open source or proprietary as already established. The difference comes down to freedom and control. Open source firmware like the PS4, Audrey Pilot, INAV, Butterflies are free to use and modify, supported by a global community of developers. good for research and startup, and especially for individual that want to actually build custom drones. You can basically tweak the drone as much as you want it to perform. Then for the proprietary um, firmware, that's where you have the likes of DJI, Skydrones. They are closed system, and most of the time, the company that owns those firmware have full control over it, and it comes with its own advantages. They are more secure and stable, but less customizable or almost impossible to customize as the end user. ID for commercial products, focus on user simplicity and safety. You can't see, you can't even edit. It's almost impossible to actually even have access to the code base for a proprietary firmware. There are several platforms where you can actually run your firmwares. Let's look at the key platforms which are common in the market right now. We have the PX4, which is actually a model, which is modular, simple and easy to use. We have the Audi Pilot, which is also similar like the PX4, very flexible. And I think the major advantage over the PX4, or the key difference is Audi Pilot actually support many hardwares compared to PX4. Now, the third platform is Better Flight. Better Flights is basically designed for FPV racing drones. And these guys, Better Flight, prioritize speed, agility, and customization for racing pilots. You don't want to do anything with racing, I advise you just focus on your PX4 or Audi pilots. Dedicated firmware's sensor fusion algorithm. But before I actually deep dive and explain this, let me explain what sensor fusion is. It's how your drone makes sense of all the data it receives from different sensors. And this sensor include your accelerometer that controls your movement, your gyroscope for your rotation, your magnetometer controls your direction, barometer for altitude, and your GPS for location. But what does this really do? Firmware fusion uses algorithm like the extended camera filter, that is the EKF that is there, to combine filters, to combine and filter all this sensor data. You know, if you are working with sensors, they have a lot of noise. So this EKF help in filtering those noise and give you accurate data. This results in a very accurate estimation of the drone's position, speed, and orientation. Note that without this, the drone would not fly well, or possibly flying blind and very, very unstable. Part of the firmware is in common in UAVs. We have your PID controllers. Your PID, which is your proportional integral derivative, controller balance the drone orientation and speed. Firmware uses PID tuning for flight stability. If you want to actually tune your drone to perform as you want it to do, that is where you tune your PID. We have your PWM firmware. Firmware are two PWM signal to control your motor speed. Think of your PWM like your knob. You have your radio knob. The more you actually increases your knob, the pulse speed modulation actually open up and expand, which in return increases the speed of your motor. For instance, now If you now decide to reduce the knob or the gap start closing up, which eventually reduces the speed of your motor. We have the fail-safe mechanism, which is also a firmware. And use cases are where you have lost GPS signal, it activates and return to launch. There's also scenario where you have loss in communication with your RC, where it either returns to launch or it lands. Then we have a battery critical, then it auto lands also. Then we have telemetry and communication firmware. This helps in managing the communication between the drone itself and the person controlling it. We have different protocol for communication. We have the Mavlink, Flashcard is on communication link. We have S-Bus and what have you. The latest one are the ALRS communication or Crossfire. We rely on real-time data to ground control station, to be a mobile ground control station. Then we have firmware flashing tools. Firmware don't just sit on its own and start working. You need to actually flash it into an hardware for it to start working. The major tools we use in flashing firmware in the UAV community is either you use your mission planner for all pilots, you use your Q ground control for your PX4, and better flight configurator for FPV. That is where you have your FPV drones for raising. Then firmware can be updated several ways. It can be updated by USB flashing, your SD card boots over the air, and it's actually critical to update firmware all the time, because sometimes when you actually build a system, you might not really have all the functionalities. There'll always be bug. So at every interval, it's good to fix bug, then update your firmware to actually have an optimal performance of your system. Um, Now will actually be all this being said. I think it's time we actually have we ask questions. You ask questions and actually response to your questions.